What causes ST elevation on a 12-lead ECG when your patient is experiencing a myocardial infarction? First, we need to establish what this is right here. This is your isoelectric line. Your isoelectric line is ground zero for when your cardiac monitor begins to detect electrical current. But the thing is that that isoelectric line isn't real. It isn't representing current or flat current. Like when you see asystole during cardiac arrest, that's not flat current. That's an absence of current. The line just represents a baseline to begin from. It's kind of like this picture right here that a child might draw with stick figures, and that line underneath the stick figures. That line isn't real, but it just gives perspective so that it doesn't look like those stick figures are floating in space. Normally what happens is that the muscle cells in your ventricles, the myocytes, depolarize. There's a contraction. Then there's a brief pause where there's no measured electrical activity. And so your cardiac monitor bounces up to its baseline of the isoelectric line, and then the muscle cells in your ventricles repolarize as represented from the T wave beginning on the isoelectric line. But when a patient is experiencing a myocardial infarction, you will have an area of damaged muscle cells next to an area where there are healthy muscle cells, and that creates an imbalance between positive and negative electrical charges, and that fools the monitor into thinking that there is no electrical charge. And this extends into repolarization, where the T wave would normally be. So where the monitor thinks that there's actually no electrical activity happening, it suddenly detects repolarization, and so it autocorrects it, but it autocorrects it from the isoelectric line, so it falsely elevates it. So when we use ST elevation as a part of recognizing myocardial infarction, all we're really doing is exploiting the monitor's affinity for retreating to a safe space when there's no electrical activity.